If you ask most people to, like, picture a middle school science classroom, a very specific, almost universal image probably comes to mind.
Oh, yeah, absolutely.
I mean, you're probably picturing it right now. The humming fluorescent lights, a heavy textbook open to some flat, two-dimensional diagram of a plant cell.
Right. And a teacher just standing at a whiteboard at the front of the room.
Exactly. Writing out these totally abstract rules about how the physical world works.
It's a highly standardized, very controlled environment. And the underlying philosophy there is basically that you have to be separated from the natural world to objectively study it.
Right. But imagine for a second that you aren't staring at a whiteboard.
Okay.
Imagine you're trying to learn physics, concepts like fluid dynamics and kinetic energy, but not by memorizing a formula in a sterile room. You're learning it by reading the shape of a snowdrift outside so you can navigate your way home and actually survive a winter storm.
Which completely shatters our traditional picture of what education is supposed to look like.
It really does.
It moves science from this theoretical exercise to an immediate lived reality.
And that shift is exactly what we are unpacking today. Welcome to this deep dive into an educational revolution that is currently happening in the Arctic.
We have a really fascinating stack of sources in front of us today.
We do. We're looking at curriculum frameworks, research syntheses, and pedagogical guides for a 7th grade life science course in Alaska called BioForge.
And the mission of our deep dive today is to explore how this curriculum is just throwing out those generic, decontextualized textbooks.
Good riddance.
Right. Instead, it's actively merging modern Western science, specifically the next generation science standards, with literally 11,000 years of traditional ecological knowledge.
It's so cool. We're going to look at how this transforms the classroom into a space where science is practiced as a literal tool for community survival.
But, to understand why this curriculum had to change in the first place, we really need to think about a student's daily life.
Let's do that. Let's imagine a typical 7th grader in rural Alaska.
Okay.
Their sleep might be heavily affected by the intense seasonal cycles, extreme light in the summer, extreme darkness in the winter.
Oh, absolutely. That takes a physical toll.
Yeah, and they're juggling school stress, maybe complex family relationships, and maybe they feel this deep, profound cultural connection when they're out doing land-based subsistence activities, but then they feel totally lost when they sit down at a desk.
Right, because the school environment doesn't reflect their reality.
Exactly. The sources emphasize that for a student like this, we have to shift from passively learning about science to actively figuring out their world.
And that ties directly into this broader concept the sources introduce regarding whole person health.
Oh, right, the Alaska Cultural Standard C3.
Yes. It fundamentally redefines what we mean by health. It explains that well-being is not just physical, it's a whole system made up of 5 connected dimensions.
Social, emotional, physical, intellectual, and spiritual, right?
Exactly. And it's so important to clarify that in this context, spiritual well-being isn't limited to one religion or, some imposed belief system.
Okay, so what does it mean here?
It's about a sense of purpose. It's your identity, your values, your connection to the land, and to your cultural heritage.
That makes a lot of sense. So health isn't about achieving some state of perfection.
No, not at all. It's not constant happiness or maximum productivity or just personal discipline. It's this ongoing process.
Right, like noticing your needs, making reasonable choices, and just responding when something in the system requires attention.
Because it is a system. When one part of that system changes, the other parts are affected too.
Which brings us back to the classroom. Historically, science education in rural Alaska has basically been imported from the outside.
Yeah, exactly. A student in a remote village on the tundra might be asked to memorize facts about an oak tree ecosystem.
A biome they've literally never seen.
Right. They can't interact with it at all. That is the definition of just learning about something.
But the BioForge framework pivots to figuring out. They use place-based, authentic local phenomena as the starting point.
Yes. The sources mention things like tracking the return of the sockeye salmon.
Or observing the cyclical population boom and bust of lynx and snowshoe hares.
Or even studying how a forest regrows after a massive spruce bark beetle outbreak.
And to teach those local phenomena, they use a really unique framework.
They do. So the standard next generation science standards use a 3D model.
Right, so you've got disciplinary core ideas, which is the what, like gravity or
And
photosynthesis.
science and engineering practices, the how, running experiments, analyzing data.
And cross-cutting concepts, which is the lens, like seeing how systems interact.
Exactly. But Bioforge adds two crucial pillars for rural environments, turning it into a 5D framework.
And those are student interest and sociocultural identity.
Right.
Okay, I'm going to push back on this for a second.
Go for it.
Because I can totally hear someone listening right now wondering, wait, isn't science supposed to be universal? Like, why are we focusing so hyper-locally on a student's sociocultural identity? I mean, gravity works the exact same way in Anchorage as it does in New York City.
That's a fair question.
Shouldn't we just be teaching the universal laws and, letting them apply it later?
Well, the laws of physics and biology are absolutely universal, yes. But the pathway a human brain takes to understand them is highly contextual.
Okay, unpack that a bit.
Think about it. A rural Alaskan youth has an incredibly sophisticated foundation of informal science experience.
Right.
They might know animal husbandry, tracking, or how to navigate a completely featureless tundra in a whiteout.
Wow, yeah. And traditional schools usually just ignore that completely.
Exactly. And if you teach science as a purely abstract concept that's totally disconnected from the reality, you put this massive cognitive barrier between them and the material.
It's like the difference between forcing someone to memorize a written recipe versus letting them actually cook a meal when they're starving.
That is a perfect analogy. By centering the instruction on a local phenomenon they already care about, you're validating their lived experience.
You're saying, hey, what you already know is a rigorous foundation for scientific inquiry.
Precisely. Which brings us to a concept the sources call bridging the two rivers of knowledge.
Okay, let's unpack this. We're talking about merging Western scientific standards with traditional ecological knowledge, or tech.
Yes, tech. And this is so important. Tech acts as a 10,000-year-old climate and biological database that's been passed down orally.
It's not just folklore.
Not at all. It is a highly complex system of biophysical observations.
We're talking centuries of continual longitudinal data collection, weather patterns, animal migration, ecosystem health.
And what we see in the Bioforge curriculum is how directly these cultural observations map onto rigorous modern scientific standards.
The example in the sources that really drove this home for me came from an Inupiaq elder named Jonas Ramoth.
Oh, the wind example. That is fascinating.
It really is. He describes local wind phenomena through this cultural lens. He calls the west wind the poor artist.
Because it's erratic, right?
Yeah, it's erratic, it's freezing, and it builds these messy, totally unpredictable snowdrifts.
Right.
But the east wind is the beautiful artist. It carves long, straight, consistent drifts that hunters actually rely on to navigate the wilderness in the winter.
Now, in a traditional classroom, a student might hear that story in a history or literature context and then just move on.
Yeah, they'd treat it like a myth.
But in Bioforge, they test it.
That's the crazy part. They take that traditional ecological knowledge and build actual wind tunnel models in the classroom using sand or artificial snow.
And they analyze the mechanics of it. They aren't just saying, oh, the elder is right.
No, they're studying wind shear, like how layers of air move at different speeds.
And kinetic energy transfer.
Exactly. They map out atmospheric convection currents to prove that the elder's observation is a perfectly accurate, empirically testable description of fluid dynamics.
It's brilliant. And they do something very similar with star navigation.
Oh, yes. Yupik hunters have navigated the tundra during the long winter night for generations without any GPS.
Right. They use the stars, the orientation of frozen grass under the snow, and those wind-carved snow waves we just talked about.
The mechanics of how they do the star navigation are just amazing.
Tell us how it works.
The sources detail how they measure the height of a specific star, the Gamma star, in the Tunturiac constellation.
And they obviously don't have a sextant or a telescope out there.
Nope. They literally stand on the tundra, extend their arm fully, and use this incredibly rigorous mathematical system of hand spans and finger widths.
So they're essentially using their own anatomy as a protractor to measure the degrees of the star above the horizon.
Yeah. It is applied geometry and spatial physics in action.
And when students learn this method, they're meeting the higher national science standards for analyzing and interpreting data.
But they're doing it through the technology developed by their ancestors.
It proves that diverse cultures contribute equally valid, highly sophisticated data to our scientific understanding of the world.
But, if you spend enough time out on the land, tracking snow waves and star alignments, You really can't help but notice when the environment starts to change.
No, you can't. And this leads to a foundational concept in the curriculum called the One Health paradigm.
Right, which ties right back into that standard we discussed, redefining what health means.
Exactly. The One Health paradigm is the scientific understanding that the health of people is inextricably linked to the health of the animals and the environment they share.
You just cannot teach life science in the Arctic today without teaching environmental change and human infrastructure.
They're completely inseparable.
And the curriculum explicitly shows how this systemic interaction plays out. Like, they use a devastatingly clear example with permafrost thaw in rural villages.
Yes, like the village of Nunapachuk,
Right. The ground there is literally thawing and subsiding.
which causes a catastrophic terrain collapse.
Yeah.
The Yupik word for it is ustek.
Ustek. Okay. And as the ground sinks, the village's municipal water facility, the washateria, starts leaning.
At a 20-degree angle.
Oh, man.
Yeah, it becomes structurally unsafe, and eventually it has to close.
And the closure of that one facility triggers a massive cascade of systemic failures.
It's the domino effect. Without the washateria, families instantly lose access to piped water for basic hygiene and sanitation.
So residents are literally forced to manually haul water and use what are called honey buckets for human waste.
And the physical health consequences of that are immediate.
Yeah, the data in the sources shows direct statistical links to elevated hospital visits for severe respiratory diseases and skin infections,
There are massive spikes in invasive pneumococcal disease in children.
which means severe bacterial infections like pneumonia or meningitis caused by the lack of sanitation.
Here's where it gets really interesting, though, if you look at it from that whole person health perspective. A warming patch of Earth translates directly into a life-threatening infection in a child.
It's all connected. Let's map that onto the 5 dimensions of whole person health we discussed earlier.
Okay, yeah. Think about a student living through that. Their physical well-being is clearly compromised by the risk of infection.
Right. And their social and emotional well-being are strained to the breaking point by the grueling, incredibly stressful labor of hauling water and waste in sub-zero temperatures.
And what about intellectual well-being?
It's severely limited. I mean, the structural barrier of failing infrastructure might cause their school to close, or their cognitive load is just entirely consumed by daily survival tasks, leaving no room for curiosity or learning.
And their spiritual well-being, that connection to their culture and land, is threatened because their ancestral home is quite literally collapsing into the river.
It really illustrates a crucial point the curriculum makes. You cannot willpower or self-care your way out of a collapsed municipal water system.
No, you can't. There is a massive difference between personal lifestyle choices and the institutional or structural barriers these communities face.
Things like geographic isolation, poverty, limited services.
Exactly. Not every health problem can be solved through sheer willpower or trying harder.
This systemic disruption also severely impacts food security, right?
Oh, heavily. In Alaska, access to traditional foods is vital for physical and cultural survival.
And thawing permafrost causes traditional underground ice cellars to melt.
Right. These cellars have safely frozen and stored whale, seal, and walrus meat for generations. Now suddenly they're vulnerable to bacterial contamination.
Then there are the clam camps mentioned in the sources.
Oh, yes. As ocean waters warm, students are working with the Sitka tribe of Alaska to actively monitor the coastline for harmful algal blooms.
They're out there using microscopes to identify the toxic algae that causes paralytic shellfish poisoning.
They're acting as frontline community scientists, providing ground truth data to protect their local food supply.
It's literally public health monitoring functioning as a 7th grade science curriculum.
It's incredible.
But I have to pause here because honestly, I'm struggling with this a bit.
What do you mean?
We're asking 12 and 13-year-olds to monitor toxic algae, analyze permafrost collapse, and watch their town's infrastructure sink into the mud.
That's a lot.
It's an overwhelming cognitive load. I mean, if a kid is terrified about their town's water supply, how do educators design a classroom that actually helps them solve these problems without just completely shutting down from anxiety?
That is the big question, and it requires an entirely different approach to the physical and social architecture of the classroom.
Okay, how so?
Well, the sources delve deep into the engineering and psychological constraints of learning in these environments.
Let's start with the engineering side.
From an engineering standpoint, you can't just take a blueprint for a water plant from Ohio and build it in the Arctic.
Right, you can't bury water pipes because of the permafrost.
Exactly. So engineers use above-ground utilidors wrapped in electrical heat tape.
And you have to design around cultural realities too, right?
Yes. The sources mention that if a water treatment system is so complex that only one highly trained operator can run it, what happens when that operator needs to take a month of leave during the seasonal subsistence hunting window?
Because they have to feed their family.
Exactly. If they leave, the whole town loses water.
Wow. So engineering in Alaska really requires co-designing with the community to balance biological criteria against logistical and cultural constraints.
It does. But to your point about the students' cognitive load, asking them to conceptualize solutions for these existential threats is daunting.
Very daunting.
So the curriculum specifically targets psychological barriers known as belonging uncertainty and stereotype threat.
Okay, stereotype threat. If you ever try to do complex math while someone is actively evaluating you for a job, you know exactly what this feels like.
Your brain just halts.
Yeah. For marginalized students, they're often hypersensitive to environmental signals, suggesting they don't belong in STEM.
Right. So if they hit a frustrating roadblock in an experiment, they don't view it as a normal part of the scientific process.
They view it as definitive proof that they aren't meant to be scientists.
And that forces the brain into avoidance and rigid thinking. When a student feels isolated or threatened, their cortisol levels, the primary stress hormone, they just spike.
And high cortisol actively suppresses metacognition and attention.
Exactly.
It's like a computer running too many heavy background programs.
That's a great way to put it.
If your brain is constantly running a program asking, do I belong here? Am I safe? Is the teacher judging me? All your processing power is diverted to anxiety.
You don't have enough RAM left to figure out the fluid dynamics of a snowdrift.
Right. So how do they fix that?
To dismantle that, Bioforge utilizes a fascinating, somewhat disruptive methodology called visibly randomized groups, or VRG.
Okay, wait. Visibly randomized, meaning the teacher doesn't carefully pick the groups.
Right.
A little bit skeptical. If a student is dealing with the structural trauma of their village thawing, how does drawing names out of a hat for a science project act as anything more than a Band-Aid?
It actually comes down to neurobiology. Research shows that when teachers carefully engineer groups, say, strategically pairing a high-achieving student with a struggling student, the students instantly perceive the unspoken hierarchy.
Oh, interesting. They know exactly why they were grouped together.
Yes, and in those teacher-engineered groups, 80% of students default to a passive mindset.
They just wait for instructions or let the smart kid do all the work.
Exactly.
So how does randomizing them change that biological response?
If the students see that the groups are completely random, like drawing playing cards or rolling dice in front of the whole class, it removes the anxiety of being judged, categorized, or ranked by the teacher.
Yeah.
That visibly fair process instantly lowers the cortisol stress response.
And because they feel socially safe, their brain chemistry actually changes.
Yes. The drop in cortisol, combined with the social safety of a random peer group, triggers the release of oxytocin and dopamine.
Wow.
Emotional safety isn't just a feel-good concept. It is a biological prerequisite for high-level scientific thinking.
That makes total sense. That dopamine and oxytocin cocktail activates the prefrontal cortex,
Right.
which is the part of the brain responsible for self-regulation, complex decision-making, taking intellectual risks, persistence, all of it.
You literally cannot ask a student to solve a community-level engineering problem if their prefrontal cortex is paralyzed by anxiety.
And this creates an environment where support seeking is viewed as a fundamental strength.
Which ties directly back to that idea of whole person health we started with. The curriculum teaches that recognizing you need help is a vital part of the scientific process.
Sometimes that just means asking your randomized group members to check your math.
Or relying on classroom routines.
But sometimes, for those bigger concerns outside of school, it means recognizing that you need help from a counselor, a medical professional, a responsible adult, or even an emergency service.
And reaching out isn't a failure. It is a feature of a healthy system.
Right. The health of the local ecosystem, the structural integrity of the community's infrastructure, the emotional safety of the classroom, and the cognitive development of the student, they aren't separate issues.
No, they are all interconnected nodes in one dynamic system.
So what does this all mean for you, the listener?
When we step back and look at this entire stack of sources on the BioForge curriculum, the big takeaway is this profound shift in how we define education and wellness.
Science isn't just a list of vocabulary words you memorize to pass a standardized test.
It challenges us to look at our own surroundings.
Yeah. If an Alaskan seventh grader's laboratory is the thawing permafrost, the shifting salmon runs, and the shape of the wind in the snow, what is the hidden laboratory in your own backyard that you've been completely ignoring?
How might looking at your own local environment through the lens of traditional ecological knowledge completely reshape how you understand the global systems operating all around you?
It's a lot to think about. Whether you're looking at a changing forest, a failing municipal water system, or your own state of mind, the core message remains the exact same.
Health is not a test you pass.
No, it is a relationship you maintain with your body, your mind, your community, your culture, your surroundings, and your sources of meaning.
Thank you for joining us as we unpack this incredible intersection of culture, science, and whole person health.
We'll see you next time on The Deep Dive. Stay curious.